Students, today we will begin studying the liver. The liver is the largest gland in the human body. It is also the largest digestive gland in the body. The liver has a very rich blood supply. Therefore, the liver in a living body appears reddish-brown. The liver's texture is soft and fragile. It is easily ruptured by external impact. This can lead to massive hemorrhage within the abdominal cavity. The functions of the liver are extremely complex. It is the most metabolically active organ in the body. It is involved not only in the synthesis, transformation, and decomposition of substances such as proteins, lipids, carbohydrates, and vitamins, but also in the transformation and detoxification of substances like hormones and drugs. The liver also has important functions such as secretion, bile production, phagocytosis, defense, and hematopoiesis during the embryonic period. Next, let's look at the morphology of the liver. The liver is irregularly wedge-shaped. It can be divided into two surfaces, superior and inferior, and four borders, anterior, posterior, left, and right. The superior surface is convex. It is in contact with the diaphragm. Hence, it is also called the diaphragmatic surface. The diaphragmatic surface has the sagittally positioned falciform ligament attached. This divides the liver into the left and right lobes. The left lobe is small and thin. The right lobe is large and thick. The posterior part of the diaphragmatic surface lacks peritoneum. The uncovered area is called the bare area. To the left of the bare area, there is a relatively wide groove, called the sulcus for the vena cava. It contains the inferior vena cava. The inferior surface is uneven. It is adjacent to some abdominal organs, also called the visceral surface. On the visceral surface, there are three grooves roughly forming an H shape. The transverse groove is located in the center of the visceral surface. The left and right hepatic ducts, the left and right branches of the proper hepatic artery, the left and right branches of the hepatic portal vein, and the nerves and lymphatic vessels of the liver, among other structures, enter and exit here. Hence, it is called the porta hepatis. These structures of the porta hepatis are enveloped by connective tissue, forming the hepatic pedicle. The positional relationships of the main structures in the hepatic pedicle is as follows. The left and right hepatic ducts are anterior. The left and right branches of the proper hepatic artery are in the middle. The left and right branches of the hepatic portal vein are posterior. The left longitudinal groove is narrow and deep. The anterior part of the groove contains the ligamentum teres hepatis, called the fissure for the ligamentum teres hepatis. The posterior part accommodates the ligamentum venosum, called the fissure for the ligamentum venosum. The ligamentum teres hepatis is formed by the obliterated umbilical vein from the fetal period. It descends through the free edge of the falciform ligament to the umbilicus. The ligamentum venosum is formed by the obliterated ductus venosus from the fetal period. The right longitudinal groove is wide and shallow. The anterior part of the groove is a shallow fossa. It accommodates the gallbladder. Hence, it is called the fossa for the gallbladder. The posterior part is the sulcus for the vena cava. It accommodates the inferior vena cava. The sulcus for the vena cava extends from the posterior superior aspect into the diaphragmatic surface of the liver. Although this groove is not connected to the fossa for the gallbladder, it can be considered the right longitudinal groove of the porta hepatis. At the superior end of the sulcus for the vena cava, the left, middle, and right hepatic veins exit the liver and immediately drain into the inferior vena cava. Therefore, clinicians often call the superior end of this groove the second porta hepatis. Having looked at the morphology of the liver, next, let's examine its position and relationships. Most of the liver is located in the right hypochondriac region and the epigastric region. A smaller part is located in the left hypochondriac region. The anterior part of the diaphragmatic surface is covered by the ribs. Only between the left and right costal arches in the epigastric region is a small part exposed below the xiphoid process, directly contacting the anterior abdominal wall. When the epigastric region and right hypochondriac region suffer violent impact, or rib fractures occur, the liver may be injured and ruptured. Next, let's look at the surface projection of the liver. The superior border of the liver corresponds to the dome of the diaphragm. It can be represented by a line connecting the following 3 points, namely, the intersection of the right midclavicular line and the fifth rib, the intersection of the anterior median line and the xiphisternal joint, and the intersection of the left midclavicular line and the fifth intercostal space. The inferior border of the liver corresponds to its anterior border. On the right side, it aligns with the right costal arch. In the middle, it is located about 3 centimeters below the xiphoid process. On the left side, it is covered by the costal arch. Therefore, during physical examination, the liver cannot be palpated below the right costal arch. However, in healthy children under 3 years old, due to the smaller abdominal cavity volume and the relatively larger size of the liver, the anterior border of the liver is often 1.5 to 2 centimeters below the right costal arch. After the age of 7, it cannot be palpated below the right costal arch. If it can be palpated, then pathological hepatomegaly should be considered. The relationships of the liver: superiorly, it is adjacent to the diaphragm. Above the diaphragm are the right pleural cavity, right lung, and heart, etc. Therefore, liver abscesses can sometimes adhere to the diaphragm and penetrate through the diaphragm to invade the right lung, and even their contents can be discharged through the bronchi. The inferior surface of the right lobe is adjacent anteriorly to the right colic flexure. In the middle, near the porta hepatis, it is adjacent to the superior part of the duodenum, and posteriorly, it is adjacent to the right adrenal gland and right kidney. The inferior surface of the left lobe is adjacent to the anterior wall of the stomach. Posterior-superiorly, it is adjacent to the esophagus abdomen. The liver is connected to the inferior surface of the diaphragm and the anterior abdominal wall by the falciform ligament and coronary ligament. Thus, during respiration, the liver can move up and down with the diaphragm. During quiet breathing, the range of the liver's up and down movement is 2 to 3 centimeters. Students, in this lesson, we have studied the position and morphology of the liver. Next, we will proceed to study other organs.